So we are here for science. And this week we are being astronomers and we are studying the sky. So let's talk a little bit about what we did yesterday. Yesterday, if we already knew it was a refresher, and there were some new things here that we learned also, right? We learned and found out and reminded that the Earth moves around the sun. We talked about how the moon moves around the Earth. We found out that the sun is not just the sun, but it's actually a star, and it's the closest star to Earth. And that stars make their own light and their own heat. Well, today what we're going to be talking about is the patterns that we see during the day and during the night. Now, this is so great because in math, a few weeks ago, we had just wrapped up, we're doing money now, but last week or 2 weeks ago, we were doing time. So talking about AM and PM and the length of a day, right? We know that a day lasts 24 hours, right? And that a new day starts at midnight, right? At 12 a.m. And that half of the day is done at 12 p.m. at midday. And then there's another 12 hours of the day, and it's 12 a.m. midnight again. It's the next day. So we're going to be talking about some of the patterns in the sky that we can observe while, how did we figure that out? How did anyone figure out that there are 24 hours in a day? That there was a way to measure time. So we're going to see the patterns that happen in the natural world and figure that out. So let's dive in. So day and night patterns. Have you guys seen this scene before? That is, I believe, from The Lion King, right? And we see the sun rising up, right? Now the sun looks like the sun appears to be moving up in the sky. And see right here, see that line right here where the sky seems to meet the earth, where the sky meets the land? That line is called the horizon. And during the sunrise is when we see the sun come up over the horizon. But now we could see a very similar thing, right? This is the sunrise, when the sun rises up in the sky. At sunset, the sun does a very similar thing, and the sun appears to go down, and it goes below the horizon. So we see one thing in the morning where it comes up in the morning, and at the end of the day, we see it go down, right? And during the middle of the day, the sun seems to move across the sky. Now, the sun for us will always rise in the east. Always, 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 right? It happens yesterday, it happened the day before that, it will happen today, it will happen tomorrow, right? There are patterns in nature that we can recognize. That way we can predict. The sun has always risen in the east. I can predict that tomorrow it will rise in the east. Well, it rises in the east and it comes up over the horizon and it moves during the day, right? Or it appears to move during the day. And it sets or appears to go below the horizon in the west. And the same thing, it does that every day too. So I can always predict that the sun will set in the west. So the sun doesn't actually move. What did we talk about? That the earth moves around the sun. And because the earth moves around the sun, it makes it look like to us that the sun is moving, right? So the earth moves around the sun. And as it moves around the sun, it also spins. So let me give you an idea of what I'm talking about. Let's say that this is the earth. You know what? Let me do something better. Let's say this is the earth, right? And all day long, right? The sun is here. And the sun rises and the sun sets. But think about it, right? The earth spins. And as the earth spins, it appears like the sun moves. Here's my sun. See how the light is shining on the ball? But as the ball spins, the light is on different parts of the ball, right? So this side of the ball which is where I had started it facing the other way, it's now in the light. It's now in the sun. So the sun appears to rise on the east and set in the west. So when that happens, that's how long a day takes, right? One full rotation, one full spin of the earth, when the sun rises and then the sun sets and it's a new day, that's one day. So the earth spins completely once a day. But while it's doing this, I'm going to put my light this way just so I don't shine it right into the computer. As it's doing this, or I can go like this. As it's doing this, the earth is also going around the sun. So it's spinning, but it's also traveling around the sun. So it's spinning and traveling around at the same time. Now, I know it's hard to picture that with Miss Egan's flashlight and a ball. So let's take a little closer look. So there's the sun right there in the middle, right? And there's the earth. And see this blue circle? The earth travels that circle around the sun. And it takes 365 days in order to do that. That's a full whole year. So where the earth is right now in relation to the sun, it won't be here again until June 3rd, 2021. It takes a whole year for the earth to go around the sun. It takes a day for it to spin. Okay? So let's see. There's the earth spinning, right? That's the sun's hitting one part of it. Now it's hitting another part, right? And on some sides of the earth, you can see the sun, and that's daytime. And where they cannot see the sun, it's nighttime. And as it's spinning and rotating and causing day and night, it's also traveling around the sun, causing each, as the year goes on and the seasons change and all of this wonderful stuff happens. So we see the light changing, right? It appears that the sun moves in the sky, but it's because the earth moves. Now, what else do we see in the sky? What else appears like it moves? The moon. Now, as the earth spins around the sun, and as the earth spins, the moon also travels around the earth. So different parts of the day different days depend on what part of the moon and what we see of the moon, right? So the moon does not create its own light, and we're going to talk more about especially the moon tomorrow. But I just want you guys to have the idea, because as we're talking about how the earth moves around the sun and the earth also spins, the moon also travels around the earth, right? So the moon goes around, the earth spins, and the earth also goes around. And all of those things show and make it look like the sky is moving. But it's really the earth that's doing all of that movement, right? The stars don't move. The sun does not move. The earth moves and the moon moves, which is so, so crazy. So we are going to make a project, and this is going to help us figure out and show us exactly how the sun moves. We can see how the sun moves in the sky, right? But this is going to help us measure it. Have you guys ever seen one of these things before? They're called sundials. They look a little familiar to me. Do they look to you at all? Where's my clock? Where's my clock? I don't know where my clock is, guys. Do they look at all like an analog clock? They're round and they have a big hand, right? And we see some markings around it. Now, what that does is it uses the way that the sun moves to create a shadow. Because think about what we know about light. Do you guys remember when we used flashlights at school and we shined light on translucent, transparent, and last but not least, opaque objects? What happens when light shines on opaque objects? It creates a shadow. right? You can see the shadow of my hand on the board here. So we're going to use, we're going to make our own sundial. And it's going to look like this. But let me show you just a little bit. See this image down below? You can see the sun moving. And the shadow that that hand is creating is moving as well. So you guys are going to make your very own sundial. And you guys can see right now, see I have I have a paper plate and I have a pencil, and I only did one thing on it so far. But you can see Miss Egan's light is up in her ceiling, right? And it's shining down, and look at the shadow being created by the pencil, right? It's casting a shadow. And if this was outside in the sun, then the sun would create the shadow, right? You can see, not great, I know, I'm sorry. You can see the shadow that the pencil creates. Now on a sundial, this part, the hand, right? If it was on the clock, it would be a hand. On a sundial, it's called a gnomon. A gnomon. This is so cool. Sundials were the first way that ancient people were able to record time, right? They were able to create and make sense of the fact that there were days, and they recognized patterns so long ago. So here's what you're going to do. You're going to need a paper plate, or you can get a piece of paper. It doesn't have to be circular, right? I had paper plates around, so this is what I did. I'm gonna send Mom and Dad all the directions too. Now, I used a pencil. You could also use a straw or a stick or anything that's a similar shape, right? Now, you're probably gonna want Mom and Dad's help for this, but you're gonna have to find the middle of the plate. And because I'm using a pencil, or if you were using a straw, you're gonna poke it in the middle, right? If you want to also use Play-Doh, you can use Play-Doh and sit it on top and then stick your gnomon in the Play-Doh and it will stay still. You want your gnomon to stay still, right? Because the light needs to be shining on the same object all day long. Now, once you have the hole or wherever you're going to have your gnomon rest, you need to take a ruler and draw a straight line up. And that's where you'll write the number 12. Because we know, right? The sun rises over the horizon in the east. And as it appears to move throughout the day, at midday, from AM to PM, that AM to PM switch, midday, 12 o'clock noon, is when it is perfectly overhead, okay? So at 12 o'clock noon, you're gonna go outside and line this up so that the shadow goes perfectly to your number 12. And then put a rock on it or pin it to the ground or something. And you're gonna go out on each hour, each o'clock, and measure, and you can write the numbers in, where the shadow is appearing. And you will then create your own sundial. And do you think that you will be able to measure after the sun goes below the horizon, after sunset has happened? Why not? Because the sun will be down, right? And we're measuring the way the sun moves across the sky. And the sun is the source of light. After the sun goes down, right, it's getting dark out and there's no shadows being cast because the light is not shining any longer, right? We are measuring the sunlight from daytime. So remember, we practice the way shadows move, right? When a light moves on, let me do it like this. When a light is shining on an object, can you see the shadow on the board? If the light moves, the shadow moves. Now, my marker is not moving. The light is moving. So that shadow will move. Now, you're going to have so much fun with this project. It is looking like it might be a little rainy out today. So if you cannot do this today, it needs to be sunny out in order to do this. So if you can't do it today, that's a-okay. This is supposed to be fun. Do it on the next day that's sunny. And this is going to be, we're going to continue working on this. Tomorrow, we're going to talk and learn more about the moon. I introduced you a little bit that the moon moves around the earth. And we're going to talk all about the moon tomorrow. So have fun with your sundial. I hope it's sunny enough out today and that you can create it. If not, we'll work on it again tomorrow. All right. Bye, my astronomers. You did amazing.